the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello viewers, once again welcome to this platform. We shall be considering the topic, the concept of bases in chemistry. The concept of bases / alkalis in chemistry. Under this discussion today, we shall be looking at the following objectives. At the end of this class, the student is supposed to know the definition of base, the various examples of bases / alkalis, definition of alkalis, physical properties of bases / alkalis, chemical properties of bases / alkalis, uses of bases / alkalis. Now, what is a base? A base is a chemical compound that reacts with acid to produce salts and water. A reaction that is a very important reaction in chemistry that has found application in industries and even in life. This reaction is generally referred to as neutralization reaction. Any reaction that involves a base and an acid is called neutralization reaction, and the product is salts and water. Examples of bases are oxide. Bases are oxides of metals, and bases are also hydroxides of metals. We know in our elementary chemistry that group 1 elements in the periodic table are generally referred to as the alkali metals. Group 2 are referred to as the alkaline earth metals and the transitional metals. Now, oxides of these metals and hydroxides of these metals are referred to as bases. Examples of oxides of metals are we have sodium oxides, we have potassium oxide, we have magnesium oxide, we have calcium oxide that is commonly called quicklime. Examples of hydroxides of metals are we have sodium hydroxide, also known as caustic soda. We also have potassium hydroxide, we have magnesium hydroxide, we have calcium hydroxide, which is also referred to as lime water. A typical example of acid reacting with bases to form salt and water is a reaction between hydrochloric acid and sodium hydroxide to form sodium chloride salts and water. Now, what is the difference between bases and alkalis? Alkalis are actually basic hydroxides that are soluble in water. Now, all alkalis are bases, but not all bases are alkalis. Typical examples of alkalis are we have sodium hydroxide and we have potassium hydroxide. Now, what are the physical properties of bases / alkalis? First, bases have bitter tastes. Second, bases are soapy to touch. Now, third, concentrated forms of these bases are actually corrosive. They can be injurious when allowed to touch the skin, the outer layer of our body. And bases turn red litmus paper to blue. Now, what are the chemical properties of bases / alkalis? Now, the first we have considered earlier, we said acid react with bases, or bases react with acid to form salt and water, a reaction that is called neutralization reaction. Now, bases also react when you add bases, a soluble solution of a base, to any ammonium salts. Ammonia gas must be produced. When you add any base, whether it's calcium hydroxide, sodium hydroxide, or potassium hydroxide, solution to ammonium salts, it is a very important analytical test for ammonium salt to test for the presence of ammonium ion in a salt. Now, ammonia gas must be produced. This knowledge will help you so much in qualitative analysis of salt. Now, alkalis, also bases, reacts with fatty acid to produce soap. This has found very important application in industry in the process of soap making. And this reaction is referred to as saponification reaction. The reaction between fatty acid and alkalis, whether it's sodium hydroxide or potassium hydroxide, will give us the product known as soap. And that reaction is known as saponification reaction. Finally, we look at the uses of these bases / alkalis. First, bases are used, potassium hydroxide for instance, sodium hydroxide are used in the production of soap. What we said earlier is referred to as saponification reaction. They have also found application in the neutralization of acidic salts for those who are into fishery, where you consider there is a process, a step in fishery in pond preparation known as liming. That liming, carbonates are added to the soil in order to neutralize acidic soil. It is also used in therapeutics, in the treatment of stomach acidity in the events of ulcer. Know that one of the acid that is secreted in the stomach is known as the hydrochloric acid. It's a component of the gastric juice. Now, the addition of the bases such as magnesium hydroxide, which is one of the major components of the antacids sold in the market in pharmaceutical stores, like the Gestids and the rest. Now, these antacids are actually aimed in the neutralization of the acidity of our stomach in the event of the treatment of ulcer. These bases are also used in the treatment of hard water, particularly permanent hardness of water, where sodium hydroxide is used to neutralize. We know that the major components of hard water, permanent hard water, is calcium sulfate and magnesium sulfate. So by using sodium hydroxide, or what we call the caustic soda, this hard water, permanently hard water, is removed. Now finally, bases or alkalis are used in laboratory analysis of compound. Like I cited earlier, when you add sodium hydroxide solution, for instance bases, on any ammonium salt, ammonia must be produced. This is an analytical important analysis in the determination of ions in unknown samples. Now finally, I give you this class activity. The reaction between acid and base to form salt and water is called what? The reaction between fatty acid and alkalis to form soap is called what? Now, when base is added to ammonium salt, which gas is produced? Thank you for listening. Meet you on this platform some other time. Goodbye.